Hello everyone. Today we are going to talk about how to configure and build PETSc and PETSc4Py using Intel compilers. In the past, Intel Parallel Studio is a supreme bundle of development tools, including ICC, IFERT, MKL, Intel MPI, vTune, Advisor, Inspector, and so on. It is one of the most powerful and highly optimized development tool set and helped many developers over years. Nowadays, Intel One API has superseded it as the most premium Intel toolkits for program development. In this video, we demonstrate the steps to configure and build PETSc and PETSc4Py against the compilers provided by Intel Parallel Studio. The steps to configure PETSc against Intel One API are highly similar to those we have presented here. At least, the philosophy and mindset of workflow are similar, so we leave it for you to explore. Here, we assume you are using Ubuntu 24.04. Before configure and build libraries, you will need to install some necessary packages for development. For example, Build Essential, Fortran Python, OpenBLAS, and zlib. We have mentioned these packages multiple times in the other videos in which we demonstrate how we configure PETSc and other developer tools for large-scale projects. Furthermore, if you intend to make use of PETSc4Py, you are highly recommended to install Anaconda and create a distinct Conda environment for your installation and isolate it from the global Python search path. In this video, we will not demonstrate how to configure and install Intel compilers. We assume you already have a working set of Intel compilers from your Intel Parallel Studio installation on your Ubuntu system. If the Intel Parallel Studio is installed in its default path, you will find the corresponding Intel compilers, Intel MPI libraries, and highly optimized MKL math libraries in the directories shown below. Now, we are at the stage of installing Hyper before the installation of PETSc and other packages. Essentially, we are trying to configure our packages against the highly optimized libraries in Intel Parallel Studio. For instance, the Intel MPI and BLAS and LPACK inside the Intel MKL math libraries. First of all, we enter the home directory of current user. Subsequently, we create a folder called hyper_binary to keep the installed binary files. After that, we pull the latest Hyper GitHub repository to your local host and enter its subdirectory called src. Once you are done, you can start the configuration of the Hyper by specifying the prefix flag, enabling building shared libraries, and disabling Fortran components in order to save the size of installed files, if you do not work on Fortran codes. You are also advised to disable the internal BLAS and LPACK libraries of Hyper to avoid conflict with the globally installed BLAS and LPACK libraries. You are also required to specify the locations of Intel MPI libraries and include path. By default, they are typically installed inside the directory at /opt/intel/compilers/linux/mpi/intel64. Do not forget to explicitly specify the cc and cxx environment variables for Hyper, so it is guaranteed that the right MPI are used. Here, we need to be sure that we are really linking our Hyper installation against Intel compilers, instead of the Intel MPI wrappers of the GNU compilers. To check this, we can type mpic, show in the terminal. If it starts with GCC, it means this mpic is actually an Intel MPI wrapper around the GNU compiler, and this is not what we want. To guarantee that we are truly linking the Intel compilers, we have two options. Number one, before configuration, we explicitly set the environment variables of cc and cxx as mpic and mpic, respectively. Number two, we can switch the compilers used in MPI wrappers using export i_cc equals icc, export i_cxx equals ic, and export i_mpi_f90 equals ifert. Either way will work for our installation to truly link with Intel compilers. Finally, after make and make install, we need to set values for the environment variables associated with Hyper in bashir file, so PETSc can find it later on. After that, we have finished our installation of Hyper. Now, we are ready to install PETSc. Similar to Hyper, we enter the home directory. Create a folder called PETSc_binary to store the installed binary files of PETSc. Extract the tarball of latest PETSc and enter its root directory. After that, we start the configuration of PETSc installation by specifying the prefix flag, disabling the debugging mode, enabling building the shared libraries, and specifying the correct path of Intel MPI libraries. To maximize the benefit of Intel Parallel Studio, we let PETSc make use of the BLOS and LPACK inside the Intel MKL math libraries by specifying the path of MKL libraries. We are also required to explicitly specify the with CC, with CXX, and with FC flags in configuration and point them to the Intel MPI libraries. Except for these, the rest of the configuration options are the same to what we had demonstrated in another video, which is about the configuration of PETSc with respect to the GNU compilers. Here, we highlight again that we are supposed to double-check the MPI options in configuration, so that we are truly linking PETSc with respect to the Intel compilers, instead of the Intel MPI wrappers around the GNU compiler. This can be resolved by specifying some environment variables of the compilers before our configuration of PETSc. After configuration, make install, we will add some environment variables inside the BARC file, so our program can find and link to PETSc libraries. Although it is not necessary, you are highly recommended to install Anaconda and create a separate Conda environment for your PETSc4Py installation, if you subsequently plan to program PETSc codes in Python. Take note that we need to include no default packages flag during the creation of Conda environment. Once we enter the created Conda environment, we will install NumPy and Cython first. We also create the env_var.sh files inside the activate.d and deactivate.d folders, respectively. In each of them, we not only isolate the Python searching path inside this Conda environment, but reset the Python searching path while exiting this Conda environment. It can completely avoid the installed Python packages inside and outside this Conda environment from polluting each other. After all these preparation, we can start installing PETSc4Py now. We enter the home directory of current user, create a folder called PETSc4Py_binary for binary files of this installation. We then extract the tarball of the latest PETSc4Py, enter it, and specify some environment variables associated with pre-installed Intel MPI and Intel compilers. You should pay attention to the double I inside MPIAC while specifying the used Intel MPI library. Following that, we install MPI4Py with respect to the correct Intel MPI library, which is MPIAC and PETSc4Py, with a specified location for its binary files. After you complete all these steps, now, you have a clean installation of PETSc and PETSc4Py against the Intel compilers, MPI, and MKL math libraries provided by Intel Parallel Studio.